To understand length of projection and projection vector, or actually the whole of this chapter relies on whether you understand this magic triangle. Okay, so there are two things over here. This is called the length of projection and projection vector, as well as the next page is going to be talking about the perpendicular distance. Okay, but it all depends on whether you understand this thing called the magic triangle that I'm going to explain to you right now. Okay, so assuming that now this is a floor. Okay, so this is you are on the floor. The sun is shining brightly today, and I am shining on this beam, okay, which I can put it as a vector called A. So when I'm shining on this beam, this vector casts a shadow over here on the floor, and this is called the length of projection, which I'm interested to find out. I call this L. So you realize that as I do this, I'm getting a right angle triangle already. Okay? Now, I do not know what is the vector of L. If I know what is the vector of L, then it will be easy. I can just, go and find out the magnitude of L, and that's it. Okay? I do not know the vector of L. I may know a certain vector. So I may know a certain vector that is called B, that runs something like this. I may know that the vector of this whole floor, I will label this as B. Okay? I do not know what is B. I know what is A. Okay, you know what is the length of the beam. I do not know what is B, but I'm interested to find out what is the shadow that is being cast, and that is called the length of projection. So between A and B, there is this angle that is down here, okay, that is called theta. So first, let's look at this. If theta is here, A would be the hypotenuse. B would, or rather L would be the adjacent length that you are looking for, okay? We are talking about cosine theta is equals to adjacent over hypotenuse. And adjacent, that would be L, hypotenuse would be magnitude of A. Okay? So next, I cross multiply. Oh, the magnitude of A cosine theta is just going to be equals to L. Now, I cannot just introduce multiply by B on both sides, even though it feels like so to make it, because B is very long. B is infinitely long, which I don't know when will it end. But I know that there is a 1 that is on the outside here, because 1 times anything is 1, right or not? So mathematically, we are still equals down here, okay? And this 1 is a unit vector. Why? Because the length is 1. I need to know what, okay, I need to use a unit vector that share a common angle, that share the theta with A. Who shares the theta with A? You got A here, you got theta here, you got B. So I need the B hat, okay? I can say that the 1 is the same as the magnitude of B hat because the magnitude of a unit vector is 1, okay? And I'm going to keep on writing all this. Cosine theta, okay, is equals to L. And what is this? This would tells you that I am looking for A dot B hat equals to L. But sometimes A dot B hat will give you a negative value, right? So I need the positive value of A dot B hat equals to L. And that is how, okay, I get the length of projection, which is the modulus. This is not the magnitude of A dot B hat, yeah? It is the modulus, okay, of A dot B hat. And it all comes from your right angle triangle, okay? So the L, which is the length of projection, is this. Okay, now let's say I found my length of projection already, which I know that this part is L. B, I do not know, but I can cut B into very small pieces such that I call this part of B, B hat. Okay, so if I can find the unit vector of B hat, the L, the length of this, so let's say this is 5. Let's say the length of projection, example, is equals to 5 units. Then what is the vector of here to here? What is the vector of L? L as a vector would just be called 5 times of B hat, isn't it? Right? Because B hat is a vector in one unit that is in the same direction as B. So anyway, this 5 is hypothetical 5. What was this 5? This 5 was L times of B hat. Okay, what was L? Magnitude of A dot B. Okay, and on the outside, now I cannot use the magnitude anymore because it could be a negative direction, so that's why I have to delete away this. Okay, and I'm just going to say that this is A dot B, okay, multiply by the time, A dot B is a scalar, okay, times of B hat. If I want a vector, then I use the length of projection multiplied by the unit vector. That's all. Okay, so two things, that's how we got the two formulas. Number one, the length of projection L is the modulus of A dot B hat. And A must always be the hypotenuse. B hat must always be the floor. It depends on where your angle is. This is the easiest way to remember how to do this. Okay, number two, if I want the vector, the position vector, the length, the position vector of the projection vector, I call this L, vector of L is equals to, I cannot take the modulus anymore, A dot B hat times of a unit vector, and this is going to give me a vector. Okay, this is going to give me a length. Okay, it depends on what the question wants. If the question wants the length, you use this. Okay, the question wants the vector, you use this. This is the way to understand it. Of course, if you cannot remember the formula, if you can work it out in the exam, that will be great on you. Of course, the easiest way is to just apply the formula dot product because we are looking for adjacent length, and that is alongside. That's how these two formulas, okay, comes about. So if you look at the next part, just now we already understood that if I want adjacent, okay, if I want adjacent, I'm going to use cosine. If I want the opposite length, which is the perpendicular distance, okay, I'm going to use sine because that's the opposite distance. So it comes back down to the same magic triangle over here. Okay, I'm just going to draw my own triangle because in exam you're going to draw your own triangle. Usually you will have A. A will always be the hypotenuse. Draw a dotted line down, okay, and then draw the floor. The floor is always called B. So this is A, this is B. You want to find this. This is called, I represent this as D, which is the perpendicular distance. So same thing, I'm going to use sine theta in this case. Sine theta is equals to D, the perpendicular distance, the angle have to be in between A and B, okay, over the magnitude of A because just the length. Cross multiply magnitude of A sine theta is equals to, okay, D. Okay, so what does this mean? This is the same as saying that I have a magnitude of A times 1, okay, sine theta equals to D because times 1 will still mathematically be the same thing. Then I'm just going to introduce who? Your B hat over here, okay, equals to D, and that's how D is equals to, now this guy will give you A cross B hat, right? Yeah, but I want to find the length, so I know that this guy is A cross B hat. I just need to find the magnitude of A cross B hat, okay, and I can get the answer, okay, for the perpendicular distance. Okay, and seldom they want the vector of this. So if you want the vector of this, all you need to do is to close the triangle now. So I look at this and I look at this. Okay, this is called your L vector, the projection vector, which I know it is A dot B hat times of B hat. Okay, this guy is my A. So if I want D as a vector, that would be A minus L. Okay, so just remember to get this. It's called A minus L. Okay, and this is how we use dot product to find projection vector, projection length, okay, and cross product to find perpendicular distance, okay, and vector component of the perpendicular vector.